Welcoming you all for yet another edition of 3D Graphy News. 3D Graphy News has been a platform engaging with end users from across the sectors, may it be aerospace, defense, automobile, dental, medical, heavy industries, also into now that we see that shipbuilding is also gaining a lot of traction, also oil and gas, consumer products. So there are variant options in terms of the service being offered. And 3D Graphy News, the conscious effort was for us to be a catalyst and also an information source to ensure that we become a bridge between the respondents who are actually offering these solutions and also the end users coming from various different sectors. Many who are not even aware of this technology, and many who are already aware, but they would also want to do a lot of exercise in terms of research and development when it comes to material science. So the technology will entail 3D printing, 3D scanning solutions, 3D visualization, 3D imaging, 3D design, 3D simulation, which is very, very important, and also material science, because materials are the end construct in terms of what you need in terms of a model, or it could be an end use part in various requirements that we are looking at across sectors. So it's a privilege for us to have formulated 3D Graphy as a consortium almost 8 years back, and where we have both the technology companies and also the end users both coming together, and also researchers and scientists and designers who come with a clear intention of growing with the technology. So we've done almost 43 events in the last 8 years, and that was a time for there was a time for respondents coming to us and saying that if this can be an information source where it can be an ongoing information, because events were maybe twice or thrice even in these COVID times, but physical events were always, it used to have a lag in terms of space and time. But here is a possibility that with virtual, everything is possible, and it's a faster execution, and it also helps us to be updated on what is happening new. So let me take the opportunity to invite one of the guest speakers and somebody whom we would want to interview today, an expert in the space on 3D additive manufacturing, and also somebody who is also our editorial member and from the advisor, so also guiding us in the course in terms of specifically when it comes to shipbuilding and also oil and gas with his expertise. So may I introduce Dr. Sastry Kandukuri, who is a senior principal scientist, a global additive manufacturing lead, head for DNV, who has been actively responsible for certification, also looking at an opportunity in terms of understanding metallurgy and the binding in terms of once the final part is come out, and so also certifying the machines and the product. So it's a great privilege and an opportunity for us to have an interview with him. So very good afternoon to you, and also back in Norway early in the morning maybe. So thanks for your time, for being a part of this interview. Doctor, quickly I will ask you, where did it all start when it comes to additive manufacturing, sir? And your journey from there.
Okay, so thank you, Dr. Shibu and 3D Graphy. It has been already several years interacting with you, and I'm very pleased to see your progress. And thank you for today's interview. So yes, if you ask me when I started working working with in 3D printing, it was almost 22 years ago when I moved from India to Belgium. So as a visiting scientist, so where I have seen the Catholic University Leuven, that is also called KU Leuven, where I was working also as a researcher. So where I there I have seen actually 3D printing activities are at the primitive stage. They are moving from rapid prototyping to the next stage, what you see here. So there I started, and I've been actively developing materials and technologies together with other colleagues. So I have been there for 6 years in Belgium before moving to Canada, and from there to Norway in 2007. So yeah, that is where I started working with powder manufacturers, also how the machine makers are working with, all the technologies are moving, etc. That's where everything started. Yes.
So, Doctor, what did you understand with this technology and the potential that it has for very specifically when it comes to shipbuilding and oil and gas? Because that's been your area of expertise also to an extent.
Yes, DNV continuing to work with our customers to help them to not only to source parts that are low critical, but we are working now that our customers can get very high critical parts, and that are operation critical and that are also safety critical. This is where the industry now.
Okay. So, Doctor, now, since as you are aware, in aerospace parts, you have the AS 9100 certification, which is a standard for aerospace. For a similar kind of a standard is also mentioned for shipbuilding also. For what we understand when it comes to technology, ISO 17631 is the ideal standardization, or is there a standardization very specific to DNV for additive manufacturing going forward?
So, big question, Dr. Shibu. For those people that are not quite familiar with how maritime and oil and gas works, maybe I need to give a little bit introduction about how the rules work there, and then we can go to what are the rules that are governing and manufacturing. So starting from maritime, that is actually both ships and offshore. Ships are quite normal ships, whereas the offshore is where the platforms, etc. And oil and gas is also including subsea assets. Okay, so maritime is governed with the set of some kind of a unified rules set by International Association of Classification Societies, and that gives the high level framework. And the DNV have our own rule set, and for classified parts are we call parts that requires a classification certification, or class certification. These parts must be made according to the rules, and also by the approved makers. So that makes it a very unique situation, that these manufacturers shall be pre-approved and shall always use the predefined rules. Whereas non-class parts, also there are several parts in the ship or the offshore that are not require any safety critical certification as some parts would need. So they can be actually either made using the DNV rules or maybe an equivalent standard, that is, for example, HTM or etc. So always you see these kind of parts that require class certification, parts that are not requiring class certification, you would always. So we have our rules, and we have actually strengthened or actually redefined and added additive manufacturing into maritime rules in DNV. So, and also in addition to the rules, we have also made several programs. For example, how to recognize a manufacturer, how to recognize a powder or a wire feedstock manufacturer, etc. Supply chain. Yes, that is one. When you come to the oil and gas, where most of the oil and gas rules are related to the area where these assets are operated. For example, North Sea have certain kind of requirements because of its harsh environment, whereas in shallow waters, for example, in coast of Africa or somewhere, maybe the rules or the requirements could be different. Of course, again in oil and gas, you have some unified requirements that are followed even geographically. For example, in US, most of them follow API rules, whereas in Norway we have something called no shock rules, and yeah. So, but in all, for oil and gas, the standards that are, for example, neutral standards developed by DNV are also most respected. in addition to the other standards like NACE or API, etc. Depends on the application. So yes, operators like Equinor, Shell, Total, these kind of operators, they also work. They're also working for several years, and they also worked with us, and we have made a standard called DNV STB203. This is a baseline standard for oil and gas now, most universal. And recently, API in US also released API 20S for parts that shall go to oil and gas sector. Yes. So then you have also a lot of associated service specifications and other standards that are helping us to qualify manufacturers, supply chain, digital platforms, etc. So this is the state of art now for both maritime and oil and gas.
Right, doctor. So, so you become a key respondent for even manufacturing companies who want to get it certified, the machines to be certified and the process to be certified. They probably would look forward to your, certification for them to then deploy these machines in centers where these services can be offered in that particular for that particular sector, shipping and oil and gas. That is one way of looking at it, and also the end users also looking at procuring parts also can come to you, doctor, in terms of being so you being a key response as a catalyst in terms of ensuring that the right product is out in the market. Got it, doctor. So how do we look at an option in terms of the conventional manufacturing method? Though we understand additive manufacturing is a very efficient and a very smart way of manufacturing, because it saves a lot of time, and downtime in oil and gas and shipbuilding, the downtime is very, very critical. So, how do you think, Doctor, this additive manufacturing space has been able to position in this particular, market for shipbuilding and oil and gas?
Okay, so that's also again an interesting question where you are touching about the DNV's role, what we are doing, and how we are helping the customers, and how our customers are actually getting benefited from additive manufacturing. Two parts. Okay, so coming to our part. As you exactly mentioned, DNV is helping both one side to our end user customers, where they want to source parts. They can refer to DNV standard. And for example, in our DNV standard, we have as a chapter called purchasing requirements. So where they can go through the requirements. For example, they can define the part they are looking for is a what criticality level. For example, we have mentioned AMC 3, additive manufacturing category 1, 2, and 3. Being one is being the low critical and 3 is the highest critical part. Okay, so our end user customers, purchasing departments, once they have all those technical requirements in hand, they can refer to our standard and ask manufacturers to supply parts that comply with regulations defined in our standard. So whereas manufacturers also coming to us and say that we have an order and we want to supply parts for that, there are pre-requirements according to us to be qualified first before we could make these parts and supply. So in both edges, both sides, we help our one way end user customers to order parts that are important for them, whereas for the manufacturing sector, we qualify them and getting ready so that they will be able to supply the right parts with the right quality to their end user customers. Yes. So this is how DNV is playing role, because we know the requirements from both, and also we are a neutral party that so that we can facilitate the demand and supply in a way that both match together. Okay, so that is one, and the second part of the question what you asked, how our customers are able to benefit. For example, coming to the maritime industry, the problem is not at shipbuilding stage. At shipbuilding stage, you have time to procure parts because you are on the shore. Your shipyard is on the shore, and you can plan ahead of 1 or 2 years to source your parts to build one or several ships. We come back to this point later, but most of the important need for additive manufacturing comes in the operation where ships are sailing for months and months. When they need parts uh, to repair some equipment, as you said about the downtime is, even a crane is down or something, other asset, inside on board of ship is in, requires a spare part, probably a auxiliary engine or even main engine requires. So they always carry certain number of spare parts. Okay, so but they're always not enough. So now when they go to a shore somewhere they don't know, sometimes they will be visiting some port. Problems are when they order parts, it will take a lot of time before these parts can arrive to these ports. And there could be customs, there could be other hurdles will be there for them to. And also the biggest hurdle is ships cannot wait for parts, waiting at the port. They need to leave soon. So now additive manufacturing, as you mentioned, helping the operations of ships, that many of those parts their shore people can order for them, and these parts can be made nearby, a nearby place where there is an export of call is there, and can be handed over when they are visiting the port. Or even we have experimented, or we have seen with our customers that are working with us, like Williamson Ship Services in Singapore. They can deliver these parts through drone when the ships are waiting to come to the port. So this is how that is revolutionizing. So when you come to the shipbuilding stage, in shipbuilding, of course, you plan for procuring some number of parts, but suddenly you realize out of 100 parts, 5 parts that require for you to meet the production schedule, suddenly they are not meeting the quality. So it will take another 6 months to get those parts. So earlier they had to over plan, meaning they have to procure 200 parts if they need 150 parts. Now, but now additive manufacturing, if this is available to them around the shipbuilding stage ecosystem, so they can actually have a peace of mind that they can procure parts if they have any shortfall from the regular supply chain. So this is maritime business. But when you come to the oil and gas is more critical because especially offshore oil and gas, where as you said, any downtime will be very fatal for them to, waiting for, a small few $100 pot can actually stop them. So they always keep a lot of inventory in terms of physical. Sometimes some of the biggest oil companies told us they may have $1 billion worth of spares spread across the world around their facilities. So now we see that some of those inventories will no longer be valid after certain time because these designs have changed or something. But for just in case, you have been procuring and storing and maintaining them. So now our oil and gas customers probably get benefit of physical inventory to, for example, to 20% of their, for example, as an example, their inventory may be removed from the physical and could move to digital, meaning they are ready to print when they need, for example, with a week or 2 weeks delivery time, and this could be possible. So in this way, they can actually get benefited of reduced storage. That is one. And the second one is, of course, as you said, sometimes unplanned maintenance or some accidents or something happen, or some kind of disasters happen, so your regular supply chain is affected. So additive manufacturing can actually bring a solution that it was not even used before, but suddenly you can think of producing a part or some solution, or a number of parts through additive manufacturing. Even tools can be produced and help them to come out of that situation. So very short term and also a long term, both. So oil and gas can benefit from this. So one more thing for both oil and gas and maritime is, now they are looking for environmental friendly technologies. In the beginning, you said additive manufacturing is a environmental friendly technology because of less wastage, and you also have a clear footprint traceability, so you can actually trace. So this is an attractive way for our customers to procure parts or use it as a supply chain to meet these emission targets.
Yeah, and also there will be a digital inventory also, doctor. Now that otherwise, if you have to stack the parts, uh, it's always good. I mean, you can trace it, but here you know that this is the part that is missing, and you design it and you print it. So you're trying to ensure that the space is utilized. There is no warehousing. You don't need to stack parts. Erosion is another challenge at times for these parts, so that helps. Also, doctor, repair is also one area probably can be also looked at, because now we have a technology called DED, to do with deposition energy, direct energy deposition. I think you can get these robots to print those, and get the repair part done. So, what do you think? Which technology has maximum traction, doctor, for shipbuilding and oil and gas industry? Because again, you can't compare, because there is also carbon fiber, which is again a good material, a good polymer to look at. Maybe it could be FDM fused, deposition kind of a model manufacturing process also that can be achieved. So I think all the technology has varied options. Though I don't want to answer the same question, but I would rather want you to probably give me your inputs on this subject in terms of which technology, doctor, would be much more beneficial for this two industries.
So again, yeah. So you are touching again 2 points. One is the repair. It's how repair is. We have not touched that point. So I'll talk about repair. And second thing is which technologies are more promising or a high priority for our sectors. Okay, the first one. It is really good that you touched again about this repair, because repair was one of the low hanging fruits for shipbuilding. Because shipbuilding is again two parts. One is building new ships versus repairing the ships that are coming to the yard. So when there are ships are coming to the yard for a short time, few weeks of time to get their scheduled or unscheduled maintenance, um, this it has been very difficult for shipyards to source rightly certified parts sometimes, and also some parts that don't require certification but have a lot of lead time. So now additive manufacturing is helping to reproduce those parts, or repair those parts as if they are original parts, by by helping them to restore their condition. The new capabilities of so this we have demonstrated in Singapore. Ad worked with us, and they have we have actually certified a repair procedure for one of the parts. They can use the same repair procedure to produce, or to repair several other parts using this. So that was one of the earliest examples, and now there are many such applications are coming, and yes, there is a lot of promising future for repair, AM based repair in maritime and oil and gas. Okay, so coming back to the technologies, as you rightly mentioned, for example, there are so many technologies. But for example, DNV, when we started writing our first standard 2 years ago, when we released, we included both powder bed and wire arc additive manufacturing. These are very common. As you mentioned, DED, powder DED, and is also very common for repair. So in our second update of our standard, we have included three more technologies: the blown powder DED, and also electron beam, and also binder jetting. So all in all, these five technologies, we believe these are serving the most needs of maritime and oil and gas. But as you said, very interestingly about composites, so we are now talking with our industry partners that they are interested to bring composites also. So our standard can be used for qualifying composite parts, continuous fiber composite parts. So it will be the next also in this in the pathway, yes, for us and for our customers.
Right. Right. Thank you so much, Doctor. I think we've covered almost a lot of points and a lot of insights that you've given, and also for the organization who is really working in terms of the research and development, also to get to know what are the final best traction for the customer in terms of the larger intent is already being done. So really appreciate the work done, Doctor, at your end. And thank you so much for your time to share your insights with us. And we'll be in touch, sir. Thank you so much. Thank you for your time once again.
Thank you very much, and it's my pleasure. You're welcome. Yes.
Thank you, Doctor.